Question 4. The statement reads as follows. A car with a mass of 900 kilograms is moving east and collides with a freestanding barrier that has a mass of 3,200 kilograms. Study the following momentum versus time graph of the car and barrier below and answer the questions that follow. So what we have here is a diagram that shows the collision between the car and the barrier. So this is the starting point. Just going to indicate the starting point here, where this would be the car. Initially it had a momentum of 18,000 kg meters per second, and the initial momentum of the barrier, it was 0, right? This is the one. So the barrier had a momentum of 0 because it was standing. It was just still and not moving. So the car hit the barrier, and then the barrier started to move. Hence you see the momentum is going up in this diagram, and the car's momentum started to decrease slightly, going to a negative momentum of minus 144, right? So now let's answer the following questions. In 4.1, we are asked to state the law of conservation of linear momentum in words. So the answer to this question is the law states that the total linear momentum of an isolated system is conserved. So that is the law of conservation of linear momentum. Now let's go to question 4.2. It says that use the information given in the graph and calculate the following. So 4.2.1, we are asked to find the speed and direction of the car. So the speed and direction of the car. How are we going to find the speed and direction of the car? We know very well that this is the initial momentum of the car, and this is the final momentum of the car, right? And the statement wants us to find the final velocity and the direction of the car, right? So which means we're going to focus on this momentum here. We're going to focus on this momentum here, which is minus 144. And so the equation that we're going to use is P is equals to mv. So that is the equation of momentum. The momentum is minus 144 is equals to, so the mass of the car, let's go up. The mass of the car is equals to 900 kilograms, right? So we're just going to write that 900 kilograms. So it's 900 kilograms and then multiplied by V. Then we're going to divide by 900 both sides, 900. So the velocity of the car is equals to minus 144 over 900, and the answer that you need to get is minus 0.16 meters per second. So that is the velocity of the car. The final velocity of the car is V is equals to minus 0.16 meters per second. So which you can simply write as 0.16 meters per second. So the negative specifies the direction. Remember that the car was moving east, and because of that, we consider east to be positive, right? So the negative means that it's no longer going in that east direction, so it's going opposite of east, which is west. Hence, we're going to just say the final velocity is equal to 0.16 meters per second, and then we specify the direction, which is west. So this is the answer for 4.2.1. So now in 4.2.2, we are asked to find the impulse on the car, right? So to find the impulse of the car, we're still going to use the diagram, right? So we have our initial momentum and we have our final momentum of the car, right? So for us to find impulse, we know the equation for impulse is change in momentum is equals to force multiplied by change in t. So the change in t is formed by the final momentum minus initial momentum is equals to F multiplied by change in t. So the final momentum, as I stated, it's this one here. So it's minus 144. So it's minus 144 minus into the initial momentum. It's this one here, which is 18,000, and then equals to F times delta t, right? So it's going to be minus 144 minus 18,000 is equals to F times delta t, right? And then we're just going to add these two here. So we're going to have F delta t is equals to minus 18444 Newton per second, right? Newton second, sorry. And the direction, because we are having a negative sign, and we said east is positive, so meaning it's going in the west direction. So that is the direction of this impulse here. So now what we're going to do is we're going to do 4.3, where it says, is the collision elastic or inelastic? So for an elastic collision, the initial kinetic energy must be equals to the final kinetic energy. So therefore the system is inelastic and is elastic, sorry. So for an inelastic system, the initial kinetic energy must not be equals to the final kinetic energy. So we need to prove by using the kinetic energy formula. Fine. So now what you're going to do is we're just going to write the initial kinetic energy, which is equals to 1 over 2 mv squared initial of the car plus 1 over 2 mv squared of the barrier, right? So what's going to happen here is the initial velocity of the barrier was 0, right? Because the barrier was just standing there, it was still. So the v initial of the barrier is 0, making this whole expression equals to 0. And then we will have the initial kinetic energy being equals to 1 over 2. So for the car, the mass of the car is 900. And we need the velocity of the car, right? So for us to find that velocity of the car, we know very well that the momentum. So for us to find the initial velocity, we know the momentum initial, which is equals to 18000. We know the mass, which is equals to 900. So it's easy for us to find v, right? So meaning we're just going to say P is equals to M over, So this means we're going to say P is equals to MV. Because we want V, we're just going to divide by M both sides. So V is equals to P over M. And then momentum is equals to 18, so it's going to be 1800 divided by the mass, which is 900, right? So this would be your velocity, which would give you 20 meters per second, right? So this is the initial velocity of the car. So now the velocity of the car is equal to 20, so we're going to substitute it here and put squared, and the answer that you need to get is 180000 joules, right? And then now we want the final kinetic energy, EK final, which is equals to 1 over 2 mv squared final plus 1 over 2 mv squared final. So we're going to start with the car, so it's going to be 1 over 2, the mass of the car is 900. The velocity of the car we calculated in the previous question 4.2.1 of the final velocity of the car, and we found to be 0.16 meters per second. So you're going to square it, and then then you add plus 1 over 2, the mass of the barrier is going to be 3000. It's 3200, right? So the mass is 3200, and the velocity of the barrier, we know very well that there is the barrier there, so its momentum is this one, so P is equals to M times V, and then V is equals to P over M, which P is 18144 divided by the mass, which we were given to be 3200, so it's going to be 3200, and then the velocity would be equals to 5.67 meters per second. So we're just going to substitute that velocity here, so it's going to be 5.67 squared, and the answer that I'm getting for this here is 51,449.76, right? So the EK initial is equals to 18,000, and then the EK final is going to be equals to 51,449.6, right? So the initial kinetic energy is not the same as the final kinetic energy, so therefore we can conclude and say EK initial is not equals to EK final. So this now means now that the system is in elastic collision.